Hello, Newport Cubs, Mr. Herman and Miss Perry's biology classes. We're going to be working through this worksheet today, which is practice problems with Punnett squares. And why not make it a total alliteration? Is that the word, Mr. Herman? With Pitbull, Punnett square practice problems.
Yeah.
Holy moly, try to say that 5 times fast.
Right.
Okay? Before we ever start to attempt these genetic problems, which is just basically figuring out the probability of what the babies might be of 2 crosses, we need to know our key vocabulary. And we worked on that yesterday, and we'll continue to work on this throughout the unit. So before we step in, these words will be used throughout all of our problems. So let's review. Homozygous, that means the same alleles. And in these problems, we just represent alleles with letters. And so if this was the same allele, we would be using capital letter, or the same little letter, little letter. So I'm just gonna write big, big, or little, little. And so in these word problems, if it says homozygous, we know the mom or the dad have to have that same letters. Heterozygous, this means different alleles. And so we would have 1 capital letter and 1 little letter. When we have heterozygous, 1 can be dominant and 1 can be recessive. And the recessive allele is hidden, and we represent this by the little letter. The dominant letter, or the dominant allele, appears, is the one we see, and we represent this by a big letter. And we're also looking at the phenotypes, so these are the physical traits we have. And the genotype, which is the genes behind it. So as long as we're clear on vocab, we can then start our problems. This is again on page 11 of your packet, and I recommend that you pause the video right now and get 2 different colors. It'll make doing these problems really easy. Okay, so we paused. Now we're ready to go and do our very first problem together. Okay, so people that breed dogs often will pay more for certain colors or eye colors or temperament or whatever it might be. And so if you're a dog breeder, it's beneficial to understand the genetics behind it so you know what kind of babies you could be getting, so you know what kind of money you could be making if you're selling these pups. And so these are all just made up. These are not the real genetics behind pit bulls. So if you have a certain pit bull and you're like, oh, is this dominant or recessive? I've made these problems up just for fun, okay? But so in pit bulls, we're gonna say the allele for tan fur color is dominant. We're going to use arbitrary letters for this, but we're going to use the big T, okay, for that. So we're saying tan fur color is dominant, so that would be a big letter, over the white fur color, which is recessive. So we're using little t. A homozygous dominant tan, and they're giving us the letters, big T, pit bull is mated with a homozygous recessive white, little t, pit bull. And so the first thing we need to do is set up our square. I like to, with my colors, make one of the parents blue, and I'll make the other parent red, okay? And then at the square, we're going to cross the gametes, okay? So we're gonna do big T over here, and a little t over here. What are these representing? Well, these are representing the gametes, the sex cells. And so if this was a dad, this would represent one of his sperm. This would be another sperm. And then these are the eggs. If you remember, our gametes are haploid. They're just half of the alleles. So we have 2 alleles in a regular chromosome, but in our sex cells, or gametes, we only have half. So because they're homozygous, she can only give a T. Because they're homozygous, he can only give a big T. Why I do different colors is because if this sperm mated with this egg, then we would end up getting, we bring the color down, we bring the color across, we would get a baby that has a big T, little t. We would do this for every single square, so I'm bringing down this T, bringing across this T, bringing down this T, bringing down this across this T, and you can kind of see how I'm going. So this would be the probability of the baby pit bulls if we crossed a tan pit bull with a white pit bull. What we do then is we count up the babies and we say, are any of the babies big T, big T? Nope, in this case, no. Are any of the babies big T, little t? Yes, all of them are. So we have 4 big T, little t's. And are any of the babies little t, little t? Nope. So we would say we have a genotype ratio of 0 to 4 to 0. What's the phenotype? So what are we seeing? We have to go back to the problem and say, oh, okay, tan is dominant over white. And so if we have this big T, it dominates over the little t white. And so all of our 4 puppies would be tan and none of them would be white. The probability of getting a tan puppy from this cross would be 100%. You guys doing okay? Any questions?
Hi. I was wondering, questions. Okay, well, I know I have some questions. Are we gonna learn about chihuahuas at all ever? Or just pit bulls? Because I'm a chihuahua and I want to, learn about myself.
That was an excellent question, Roxy. I appreciate that one. Anyway, moving on, we're going to brown-eyed color. So we're now looking at the eye color of these mythical pit bulls. This isn't real. Again, these are just problems I've made up. So we're saying this brown eye color is dominant over the blue eye color. So therefore it gets a big letter. This one gets a little letter. A heterozygous is crossed with a homozygous dominant. Again, this is where the vocabulary comes in. We need to go back up and go, oh, what does heterozygous mean? That means they have different alleles. So we're saying a heterozygous, and I'll make this one the blue one, how about, is crossed with a homozygous dominant. So we need to know, we're using these letters at this point. The letters are arbitrary, they don't matter. So we're gonna say heterozygous has to be a big and a little. And this is crossed with a homozygous dominant. Homozygous has to be the same, and it's cluing us in that it's the big letter because it's saying dominant. And so we would say big B, big B. So let's pretend that this one's the male. It doesn't matter, but I'm going to say this one is the male sperm. So again, these are the sperm. And it's crossed with this one, homozygous dominant. I'm going to give you a few moments and I want you to cross over and cross down your alleles. All right, maybe you pause the video at that point and you crossed them down. Did you bring down all your blues? Did you bring across your big B's? Now, did you see what I did there? I wrote the big B in front of the little b. Doesn't really matter, but just for standardization, we usually do the capital letter before the little letter, okay? And so now we're looking at these babies, and we're gonna try to figure out the genotype ratio. We always write the genotype ratio in homozygous dominant, heterozygous, homozygous recessive. So how many of the babies are big B, big B? We're looking at these. We've got these 2. So we've got 2. How many babies are big B, little b? Oh, Marley?
There are 2 heterozygous big B's, little b's. 2. That means that one dominates over the other one.
Totally correct, Marley. We've got 2 big B, little b's. And how many little b's do we have, Big Boy Nate?
I think that it is 0. Oh, my mom got distracted for me. I gotta pay attention. 0 little b's.
Big Boy Nate, you're so smart. Yes, we've got 0 little b's, okay? From this, we need to figure out what are the eye colors, the phenotypes, the physical characteristics that we have. And so when we're looking back up here, we say, oh, okay, so dominant is B and that's blue, and it's dominant over, or sorry, dominant's the brown and that's dominant over blue, okay? So the phenotype ratio, big B would give us a brown eye. Big B, little b would also give us a brown eye because this one's hiding the blue. And we don't have any blues. And so our phenotype ratio would be 4 browns to 0 blues. What is the probability if we crossed this mom and this dad of getting a blue-eyed puppy? 0%, okay? And now our next question runs over the page, okay? So we're gonna do number 3, and I'm gonna give you some time to do number 3 by yourself. Let's read it together though. Brown-eyed color is dominant over blue-eyed color. A blue-eyed female is crossed with a heterozygous brown-eyed male. Pause the video right now, and I want you to do all of the above. I want you to figure out who are your parents, what are their alleles, how are those babies gonna cross, and what are the genotypes and the phenotype ratio. Do that now, and then we'll go over the answer together. Okay, hopefully you've paused, and we're gonna check our answers. So we've gone over and we've said brown eye is dominant, a blue-eyed female. So because we know she's blue-eyed, she has to be little b. So I'm just gonna put her here. It doesn't matter where you put those. And it's crossed with a heterozygous brown-eyed. So heterozygous is cluing us in that it's different letters, okay? So here's our dad, sperm. Here's our female, eggs. And we're gonna bring these down and cross these over. So he has a big B coming down, there's a little b coming down, and there are these little b's coming over. Genotype ratios. We always go homozygous dominant, homozygous or heterozygous, and then homozygous recessive. How many big B's do we have? Skippa.
All right, so I think that there's 44 big B's. No, 4 big B's. There's a lot of big B's is what I'm gonna say. Yes, lots of them. And I wish my son would stop eating my face. 4, that's my final answer. 4 big B's,
Oh,
big B.
Skippa, that's not right. That's okay. We don't have any big B's, okay? How many big B, little B's do we have? We have 1, 2. And how many homozygous recessive little B's do we have? 2 babies. What is our phenotype ratios? How many brown eyes do we end up having? How many blue eyes do we end up having? Okay, so this is dominant. The big is dominant over the little. We end up having 2 brown eyes. We end up having 2 blue eyes. So what's the probability of getting a blue-eyed puppy in this cross? Probability, 50%. That's it for today, you guys. We are going to go over this project or this problem in another lesson. But this that we're doing right now in these 3 problems are straight up dominance. And there's different problems that we'll learn throughout this unit. It gets a little bit more complicated, but for now, that's what we're doing today. Good job, Cubs.